Welcome to Monitoring the Power Platform Bootcamp. My name is Ali Yousefi. This is Monitoring Power Automate. Hi, welcome to another edition of Monitoring the Power Platform Bootcamp. This one we're going to do Power Automate Flow. So we're going to look at how to monitor flows at runtime and specifically how to monitor previously run flows at scale. So we're going to look at how to build a architecture that is going to allow us to track flows that have been running very frequently, even flows that we may not have access to as admins. We'll look at how we can push that to application insights. We can build Power Automate reports off of that, or integrations that'll help us build reports. We can have Power BI visualizations and build alerts using Azure Monitor. So enjoy. We'll start with session objectives and an introduction. We'll look at monitoring at runtime, including best practices and a demo. Then we'll look at collecting flow run history with best practices and a demo as well. You should be able to implement a runtime monitoring strategy. You should be able to monitor and alert on Power Automate activity, and you should be able to architect a system to collect Power Automate historical activity. So for an introduction, my name is Ali. I'm a senior customer engineer. You can find my email address and LinkedIn contact info on this slide, as well as some certifications that I have. Let's take a look at the anatomy of a flow. Overview of Microsoft Power Automate flows. Microsoft Power Automate flows is a low-code integration and workflow engine. Power Automate flows currently reside in two main areas, the My Flows area and the Solution Aware area. Both of these reside within the context of an environment. If you're unaware of what Solution Aware flows are, these are flows that reside within solutions, which are the primary driver for moving and promoting artifacts through dev, test, and production environments. Users and makers can build flows triggering for multiple events, including user manual button presses, recurrence or timer triggers, or even events that happen within services connected to Microsoft Power Automate, including Dataverse, SharePoint, OneDrive, and third-party services as well. Flows can also connect to those multiple services and perform actions. These actions, depending on the business requirements, can become complex, can include conditionals, for each loops, can run in parallel, and become very, very complex as we review the next few slides and how we're going to essentially monitor these. Finally, flows, they provide analytics at the flow level, the environment level, and recently announced tenant level. What you see here is a representation of a flow that includes a recurrence trigger. This is a trigger that is on a time interval, and also a representation of a parallel branched flow. We see three branches, left, middle, and right. Starting with left, we see two boxes. Each box is called an action. An action can connect to a service, such in this case we see add a new row and delete a row. These services can be identified by the icon in the left. The icon on the left in this instance is Dataverse. In the middle we see a branch that has an action called get items. The icon on the left for this is SharePoint. On the right branch we see HTTP and delay to. HTTP represents making an HTTP request, and you'll notice there is an orange funnel associated to the right of that. That is providing static results from the HTTP, which we will cover later. Delay to is another sort of timer action. In this case, we can delay things from happening. So we have a delay that can be based on minutes, hours, days, etc. Monitoring and alerting Microsoft Power Automate flows. What tools do we have at runtime? Well, in Microsoft Power Automate, We can find out information on the workflow. This includes the run ID, the run name, information about the workflow, including how it was triggered and who created it. Information on the triggering event. So tell me about the specific event that happened. So if this happened from, say, a Dataverse create of a record, we could find out what record, what was the scope of the record. So tell me about the initiating user. Tell me about a little bit more about the record itself. So any of the data points collected within the record. If this is a OneDrive file, say a file is being added to a OneDrive, we'll find things like the file name, the location, the size, and who created it, and so forth. Information on any action and scope. So the actions will include, what was the name of the connection being used if we're connecting to a third-party service or first-party service. It'll include the inputs and outputs for the action itself. So every action that's invoked will have some inputs that are being provided to it, and we'll provide outputs. So if I create a record or update a record in Dataverse, I expect an output to include the primary identifier, any updated properties, as well as any headers included with that call. So think of a request and response when I get a header and I get a body response. So we can collect both of those on the output as well as on the input for every action. And for scope, scope is an object that's specific to Microsoft Power Automate and Azure Logic apps that allows us to scope actions within sort of a container. This could be used for try, catch, and error handling, which we will cover later, and we can review information on those. We also have custom properties. These allow us to add tracked properties that could be from the action itself. They can also be properties that we define, such as timestamps or any identifiers that we'd like. Finally, we have delivery tools to both Azure as well as on-prem. So we can deliver to Azure log stores such as Application Insights or Log Analytics. We can deliver on-prem to SQL, to Excel workbooks, to OneDrive files, etc. So within Microsoft Power Automate Flow, we have workflow function, trigger function, and actions function. The workflow function will help us answer the question about telling me about the flow. It will return all the details about the workflow during runtime, including the name, the type, the ID, the location, the run, and tags. The run property will have name, type, and ID, and that run ID will be important as we look towards capturing the run history. The trigger has the information about the triggering event. So for instance, we have the inputs. So what was the input from the event that happened, the trigger condition, and then inside of this we have what's called trigger outputs and trigger body. Trigger body will be the output from the trigger itself, and then we have the outputs that we can use as well, which is sort of a name value pair that we'll have. Finally, we have the actions. The actions are available for every action that we have, including the scope, as we mentioned. They include their output at runtime. So there's the action body, there's the action outputs, and then body itself. If you want to see the current action you're on, you actually can run, instead of actions with an S at the end, you can run just action, and it'll give you that piece there. So if you want to look, for instance, at a property from the return on the body, say for instance you're running a Dataverse update and you want to look at a property that was returned, you could say actions, and then in single quotes put your action and go to the outputs in body. And as we look at the actions, what you'll have is the name of the action, the start and end time, tracking identifiers, status, the input objects, and outputs. So as we were just describing the outputs, we can look at the body, and we can look at the property. So we could say actions, as it shows here on the right, put single quotes, trigger object as the name of the action. and then do dot outputs, dot body, and then dot property. You can also do this for the headers as well. And you can do this for the inputs. So you can find out stuff about the tracking identifiers if you're adding any of those identifiers. What status was the action successful? Was it failed? Was it was it skipped or canceled? What's neat here is that you can also get the headers, and the headers will include correlating identifiers most of the time that we can leverage as we start monitoring these flows. To the left, you could see the trigger function being used. In this case, I'm using what's called the initialized variable action for each one of these, setting it to a type of object, and then using trigger. Each one of these trigger and actions is a JSON formatted value that we can use and then parse it and work with it. Flow scopes and error handling. So as we mentioned before, flow scopes allow us to add multiple actions within a container. If you look at this image on the left, you can see three sort of actions or blocks here. One called try, one called catch, and one called finally. You can see the box within a box is sort of the icon to help us understand this here. Inside of the try, we can put actions that we anticipate may have potential issues, such as intermittent failures, or could potentially be throttled, etc. Within that block, we can include sort of an output that will tell us if this sort of scope, everything in the scope succeeded or not. And that's done by using the result function. So in this image you see on the left, there is a result with a single quote try. So that's actually going to be captured within the catch or finally that we show here. To set this up as a try catch, on the catch scope underneath try, you can configure how it runs after, and you can set it to run only when there's a failure or a cancel, something, or a timeout, something like that. If it succeeded, you may just go directly to the finally here. But getting the result will give us what happens at the top level action. So it accepts the single parameter, which is its name, and returns an array of all of the first level actions. So think of these as the same responses from the action that you see. So if you want to work with the name of the try action, you can say .name. That'll get you that. If there was any error messages, anything in the try, you can do exception message actions.error.message. For the exception code, you can do error.code. And again, for workflow name and workflow run name, these are all examples here. This is useful for when we're going to be delivering this information to Azure or on-premise based resources. So tracked properties and identifiers. So to the left is an example of using the initialized variable for a tracked property. In this case, we are going to have the actions as the variable, but we're going to use the ellipsis on the right and click on settings. When we click on settings, we'll see an option to add tracked properties. In our case, we're adding sort of a name value pair. And here we have a name called action, and you'll have to add the value in double quotes and add the ampersand. In my case, I'm adding ampersand action to get the current action for list record. And then to get the list record status code, I can get the actions list record dot output dot status to get the status code there. When you get this, looking at additional examples down here, you can see the tracked properties before. So now I can show, okay, what was the response code from my Dataverse status call? What was other information? So these are from output headers for looking at throttling or API limits. So I can see the remaining calls and remaining time that I have. This is useful if I want to see if I'm going to potentially run into any throttling based on service protection limits. And again, these can all be added to a response. So if your workflow is going to respond back, you can add these to headers, for instance. So if I want to get the flow run name, if I want to add the response codes from any of the previous actions. I can collect these as tracked properties as well and just quickly add them to the response. For delivering to Azure Application Insights, we have two options. We can send directly using HTTP, or we can send with a custom connector. On the right, we're creating a payload that will be delivered to the HTTP action further down in the flow. In this case, it's a type of string, and I'm adding in a JSON value. So time, the instrumentation key, and then information about the event that happens. So the name, the properties, the tags, etc. So that one is useful for just quickly sending to the ingress endpoint. On the left is a custom connector. This was included as part of the Monitoring the Power Platform blog series. The sample code is out there on my GitHub. You can create a custom connector using the Swagger definition provided with an Azure function backing it. And the benefit here, as you can see, it provides us typed fields that we can then add. So referencing that previous slide that had the error messages from the try block, the workflow, etc., we can now add these in. So workflow name, environment name, workflow run name, we can add these as custom properties on a Application Insights event or exception even. To deliver to Azure Log Analytics, we can use the Log Analytics Data Collector API action. This allows me to work with custom logs within the data collector, the Log Analytics Data Collector. So I can create a custom log name, which is that second field you see on the workflow data image on the top. What's nice here is that the expected payload from the data collector API is JSON, and Power Automate, all of the workflow, the action, the trigger, all of these objects return JSON as well. So we can essentially add the entire piece, or we can create our own using things like parse JSON and create JSON objects beforehand. So in this case, I'm using the workflow function and creating a custom log name called Power Automate Flow. So this will create a table, and each one of the properties in the JSON object will become its own column. You can also add a time-generated field there. So the second one you see is actions. So I would recommend separating the workflow information from the actions. The workflows will represent the entire flow, and the actions are what's happening within. So as you can imagine, the actions could get a bit more increased in rows. It can potentially create more columns because each action has its own properties. Workflows are very consistent on what properties are within, but actions can have all sorts of output headers and bodies and so on. So it'll keep it more consistent by separating these out into two separate logs if you choose to go this way. In the bottom is an example of custom tables. So you'll see whenever you do create this in Log Analytics, it'll add the _CL to the end of your log. So in this case, you can have Power Automate _CL, Power Automate Actions _CL, Power Automate Flows _CL. This is useful too, is if you're looking at error handling. If you want to pass any of the error messages, you could just do this directly as well. So maybe your Power Automate Actions only collects failing exceptions and so on. You can get alerted on that. Okay, here's an example of working with the workflow data. So we use the workflow function here, passes JSON request. We have a Power Automate Flow, it's our custom table in Log Analytics, the trigger object as well. So we have a triggers and then actions. So we can add to each one of these here. And you can see the workflow is naturally JSON serialized. For actions, it's important what it's calling out there is that actions, if you pass in the full one, it'll start adding multiple columns. And if they're different types, if one is say a GUID and one is a string, it'll add ID. Like if they're named the same, if the property name was ID and one was a GUID and one was a string, it'll add ID _G, ID _string. And as you can imagine, that does get very cumbersome as you start building out a bigger and bigger table for the action. So be mindful of what you're passing in when you do the action. So actions are a good example of probably creating a standardized contract that you're going to adhere to. Okay, so let's look at real-time monitoring of Microsoft Power Automate flows. Okay, let's take a look at triggers, workflow, and action objects we have within the Power Automate runtime. So here's an article I wrote a couple years ago that's part of a 3-part series here for runtime with Power Automate. This first one covers trigger, workflow, and action. So for triggers, you can see here's sort of the properties you have of triggers, including custom tracking IDs, some retry policies, and adding concurrency, as well as conditions to help determine if a trigger should fire or not. You can see here there's secure input and output. You can configure if you want to secure the input and output from any run history per se. Looking here, there's some trigger condition. In this case here, adding a correlation ID that came in from a trigger body. You can see you can use the trigger body object. There's a trigger as well, but trigger body will get you what's passed in payload. In this case, I'm looking in the payload for something called correlation ID. So if you're using, say, a JSON payload here, you can add a correlating ID and whatever you want. This can be anything you want here. This is sort of a tracking ID that can be used for other requests there. Here's again the trigger object here. So here's an example of the recurrence, the name, start, end time, tracking ID. So this one shows me this is sort of on a timer. When did the trigger actually start, and when did it finish firing? This is not the flow itself, just the trigger. Here's a tracking ID we have, as well as the client tracking ID, which will be tie us to the flow name here. You can see it also shows the source history name and some client keywords. In this case, we're testing a flow out, and was the trigger successful? For common data service trigger or Dataverse, you can see this one gives us a name when it was. What's the parameters here? So in this case, we were looking at the flow approval, and this is the data set we had. You can see different items. So we have the internal ID. So we look at, this is the SDK message and the entity ID that goes along with it, as well as the different headers that were here. What's good about this is that when we're looking at the runtime and monitoring it, we can actually take pretty much anything that's inside of this trigger, and even the whole trigger itself, and send that to a log store like Application Insights, Log Analytics, what have you. So if we see something in the headers, for instance, this XMS client request ID, we know it's something that could help us if we need to troubleshoot or correlate this back to say Dynamics or Dataverse. We have that option, as well as the primary key and the action that was taken. Here's the workflow object. So this is everything this kind of describes the workflow itself. So the display name, the identifier, where it's located, and so forth, different timestamps as well. So the run object shows us the name and the ID that can get us to it. Add different tags to the workflow object. This is a big one, is the actions itself. So there's a method within Power Automate called actions. What this lets us do is look at put in a title of a previous run action, and we can get information from it, including the outputs, which is very helpful when we start looking at updating records. So in this case, we have an update a record up here. We can see the inputs that were passed into it. We have the type of object here, update record object, and the outputs of update a record. And we can see when I call that, I can see what was actually passed into it and what was back out. So again, being able to capture the status code, was it 200? What was my headers here? So my XMS request ID, again, they could be used for troubleshooting and so forth, as well as like the body that shows me the ID to the record and so on. Again, the output header here. So this one is highlighted because this correlates with the threading that we have available to us, as well as the throttling that we have. We have the request ID here, as well as the MS service request ID. You see the output body. So all of this can be captured and stored using this this actions object, which is this one here. So when we look towards the second one of this is here. Get into the tracked properties and error handling. So tracked properties allow us to add properties to each action. So if I flip over for a minute to an actual flow, we can see this tracked properties example. If I click on the ellipsis here, I now have the ability to add an action. I could say action and add maybe something up here. So if I want to say list records, then we can decide if we want to do something like output, what have you. So you can add this kind of stuff here, like so, and then run this here. You may need a little bit of a troubleshooting to figure out what it is. I do want to show you one thing that could possibly happen that I've run into, which is the track properties can only hold so much information in it. So if we back up here, look at the previous history, we can see that we get a message saying the tracked property size limit exceeded. Being that the track property size can sort of be dynamic, especially if you're looking at capturing payload responses and so on, this leads into sort of a how to handle errors when we're in our runtime here. So we'll finish up with this example of the track properties and then look at how we could sort of use an object called scope to help us perform a sort of an error handling piece for powerautomate. So we looked here, we could see it exceeded and didn't go any further. In my case here, I'm going to resubmit it. And we can see that it failed again with the same valuation failed. So in this case, this is where you can start kind of digging deeper into it. In this case, the input here, it didn't like the template actions is not expected at this location. So being able to set that here. So here's an example of one that I found helpful, was using the UTC now within Flow to set a timer, or sort of a timestamp for this one here. So we will look at saving this and running it again. So this is the actions function that we mentioned here. I can see the name and the entity name, for instance here, fetch XML that was used, the status code, including the rate limit time remaining and the burst remaining here. So I capture all this and I can really do whatever I want with it. I can start again looking deeper into it, including looking at the maybe tracked properties that were part of that, and then send that as a response. One thing I would probably say is when we're looking at the action output is collecting those headers here and again setting those here to a response. Within a response, if you have this ability to send back a response, you can add these headers to the headers as well. So if you want to sort of capture that and provide that in the response, you can do that. But let's go ahead and look at how we can sort of monitor this flow run in real time. All right, so going to runtime part 2, track properties and error handling, we can see the different ways. This is kind of the stuff I just described here, adding a delay and so on. You can see this one, I'm showing the 5-second delay track property. Handling and capturing errors and actions. This is where we start looking at each action here has different statuses it can have: successful, failed, skipped, or timed out. And you could say, okay, if this output is not equal, in this case I'm showing an example of using output header. If it's not equal to 200, do something like this. So this is a mock object up here, and we can decide if it's failing, go this way; if it's not, go that way. It could give us a chance to do some retry and so on. But here's the mock that you can do. A lot of the the actions have this, some don't. If you do have it, this is a great way to help test out flows here. And you can see you can add different error codes. Right, so getting into the try catch piece, this is what we're going to be using, which is the scope objects. If I click on this link, it should take us to the scope, which kind of lets us get context and results for failures, as it explains here. And you have the result function. So if I go back to the article, we do a try. In this case, we're purposely failing this record out and then doing a catch. And we have the catch here to catch it. Interesting of note, the CDS action here actually had the mock. I don't think the Dataverse has this currently, so we'd like to see that be available for us as we move forward to parity with the previous CDS action there. So if I want to look, I can see the actual the payload for the result function. See that it was successful try action. What was it? Was it okay? Was it not? Here's the requests that were, or excuse me, the actions that were within it. And here's a GIF showing it here. So let's take a look at that. So we'll take our previous flow we were working with here. We can see that it's been consistently failing here. So let's see what we can do to help capture this, because right now we have to go to the flow and check it out. So we know that it's failing somewhere on these. I think it was composed last. So what I want to do is add an action. Add scope. And we're going to rename it to try. And I'm going to drag. Initialize variable can be at top level. Okay. Put this here. Put these here. So apparently these have to be outside of scope. If you want to continue on through this to figure out if these things failed or not, what you can do is configure the run after. So this is showing the one above, so list records. Only run it if it was successful. So run this one. We can do configure run after. Do has failed, for instance here, and the same. And for this case, for these variables here, most likely since it's not available to put into the scope, this is where I'd probably end up doing the status, where I showed earlier on the blog post here, where I can add an action and be able to do sort of a branching and conditional to say, hey, is this something that we want to go true, like if it was successful or not, go this path. If it failed, maybe document it here. So let's take a look at that. Okay, so we have the track property example object here. If this thing possibly fails, we're doing a condition. So we're showing actions, track property example object, and then dot status. Dot status, if it's successful, we'll go this way and won't do anything. If not, we'll send data using the log analytics data collector. This one's sending it to a custom log called powerautomate failed actions. You can use the log analytics one that I'm showing you there that's out of the box. If you want to go with appinsights, there's actually another way of doing that using either HTTP connector or building your own Azure function. So to do that, it's on part 3 on this implementing a runtime strategy. You can decide kind of how you want to do this here. So log analytics connector, you'll give it a connection name, just a string that's descriptive for you. Workspace ID can be found on the overview, and the workspace key can be found within the agent. I think it's called management area of log analytics, and it'll create custom tables for you. So powerautomate actions, flows, whatever you want to call it. So in this case, I'm providing the workflow information for flows, actions, and so on. This works pretty well. Remember, with the the newer versions of appinsights, not the classic version. They're workspace based, so even if you choose to go one or the other, you're going to still have log analytics sort of as the backend data store. The benefit of log analytics, it gives you a custom table, so you have your own columns that you can kind of set how you want, where appinsights kind of has its own specific contracts that it wants. The benefits of appinsights is that if you follow those contracts, it has features on top of it as part of the service that can help build things like application maps and correlate things together, right? So if you looked at I think it's at the top here, appinsights can help you really build this out. Log analytics, you can do it, but appinsights get you the end-to-end transactions and requesting and so on here. To build your own, here's a link here, Monitoring Power Platform Custom Connections, that will show you kind of how to build it. I have sample code to help you here. This one's showing a dependency call, and you can bring that in, and you can set it to different values. So track event, I'm passing in correlating IDs, names, different workflow and action names, and so on. Some considerations here to call out, like how to work with JSON and so on, and being able to test it out with the custom connector test operation here. So all that's available. We have the source code is available here. Full sample can be downloaded here. And there's different examples for doing the zip files and so on. So there's a tester as well as some zip files that you can try out. I think this has the custom connectors and so on within it. All right, so to wrap up on the log analytics piece, here's workflow, trigger, these different things I'm passing in. That's one that's already ran. So if I look at this workflow, passing in workflow for trigger, passing in trigger, action, in this case list record, the one above it, and then this is just send data, showing how I can send custom data to this MSX log here. So we have that. So that one's kind of neat because you can kind of show how you can do a custom JSON body, including maybe bringing in workflow trigger and an action all together. So if you just want to track a failed action, maybe you want to get some of the kind of contextual information, like what was the workflow and what was the firing trigger. So when you start looking at the deeper into the run history, you have that option. So let's take a look at that, how it ran. So here's our powerautomate failed actions. We could see it's got the when it was generated, track properties example with all these different objects within it, including headers and so on here. Client tracking ID, so on here, start time, end time, whatever. And we'll run this powerautomate one here. All right, so looking at powerautomate flows, what was my flow display name, right? These are these tags that I'm adding, right? We talked about the tags. So my logic app, environment name, run name, etc. So that what's neat about that is that you can now build out queries where you want. I don't know, name. What is it? Tags flow display name here. So if you just want to search for like specific flows you want to monitor, so like you're running the COE, I don't know, flows, and you want to track those, you could add this in there and track them. So that's there, and see which ones are failing and so on. Get like a success code for it. And then we have the actions here. So delete multiple. Some of the headers you could see. Was it successful? Like if you just pass in the JSON, it's gonna make this pretty thick table here. So you might look at that last example where you can create your own custom JSON. So these are the custom logs that it creates in log analytics. So it's very flexible, but as you can see when I run this Power Automate action, just looking at the table that it does here, it'll grow quite large, and you can even get into potential different like header names, request ID. It'll put like _G, _S, capturing cookies. There might be some concern here with collecting sensitive information within payload and so on. So be very mindful of what you're doing when you do it this way here. All right, to finish up with the try catch part of it, here's the try. As part of the try, you have whatever you have inside of here. In my case, I'm purposely throwing a failed message here, disabled message. Yep, perfect. And do a catch. And I'm catching the try result. So remember, the result function is here, result of try, which is our try block. That will get us what we need, and then we can track different exceptions here. So in my case, I can actually go into the actions of try, remember, and say what was the error in message. So I can check the result of try, and if it fails, I can get stuff from it. So what was the name? What was the error message? And more stuff about it. So this one actually will run using an Azure function backend with a custom connector front end here. And this one ran, and you can see I had also a finally object to show me what was my try result. Here's the condition with all the actions skipped and so on. So if I look at the output, you can see what happened here, all the different send email, whatever it was, create CSV table, whatever, catch result. You can see this particular action was skipped, it looks like, and you can dig into each one of these and figure out this action failed. Compose 3, webhook tester, okay, track exception. So I could see there was an exception message here on the track exception, so I can capture this one and move forward on it here. So status failed. Yep. So that wraps up that example. And again, you can add headers in here that you want to return back. So in my case, I'm actually returning the just the flow run ID, so it's part of it. You can see you can add whatever you want. So flow run, this gives me the run dash name. You can add headers from actions. So if I want to do, like, if I know that this is, I don't know, dataverse insert, we could always do an expression insert, and then something like outputs. I think is it headers like this, and then whatever you're at, XMS request ID, something like that. And then when you get it, yeah, it's not liking it, but it's in here. It's inside of the output. You can get the headers, and then you'll be able to pass that back as well here. So we just completed the demo of how to do some runtime monitoring with Microsoft Power Automate flows. We'll wrap with some best practices for runtime monitoring. First, do leverage scope objects for error handling. That's our try catch finally. These scopes will allow us to have the ability to look at the top level success by using the actions, and we can dig deeper into each scope. So if we could check the high level, say, hey, actions of try, were you successful or not? If you were not, we'll find the actions within the try that were failing and report the output, for instance, to Azure Log Analytics, appinsights, etc. So do leverage for error handling. Do leverage triggering and action output objects. So the output objects will give us a lot of information about what the service is trying to tell us. So if we ran into any throttling, any error messages, if we are concerned about what the output would look like in terms of what was changed, we may have in Dataverse, we have something called plugins which represent business logic. So what you send in could invoke business logic that could actually manipulate what is coming out. So we can review what was going in with the input and then look at the output objects. Also remember the action objects include if it was a status. So what was it successful, as well as the header that gives us the service request IDs, the correlating identifiers from a service. So if we want to kind of bring all this together, I would highly recommend on every action looking at the headers and determining what the service is telling us and giving us with identifiers, providing those or logging those either back to as the HTTP response if you have that available, or storing that within a log store in Azure on-prem. Do leverage tracked properties. These can be everything from timestamps, again, to these identifiers, headers, status codes, etc. And again, as mentioned, when applicable, provide identifiers in the flow response. I would add those as in the header so that your payload looks consistent in your body, but in your headers you can add identifiers from previous actions, from first party and third party services, so that if you do need to troubleshoot, you have those in your header. So now that we've covered runtime monitoring, let's see what we can do for historical reviewing and alerting. This will be useful for not only looking back at ones that we have implemented a solid monitoring strategy using what we've covered earlier, but also looking at maybe flows that are created by makers who may not be necessarily following that strategy. So we can look at these holistically over an entire environment, how we can both collect data points as well as alert on any potential issues we would run into. So for flows, the first level is the flow level analytics. You can get here by going to the Power Automate portal, which is at flow.microsoft.com. You can choose your flow, and when you open up your flow, you'll see that there's an analytics button in the top command bar. When you click on that, you'll be presented with what you see here on the right, which includes a range you can choose. I believe it's 7 days, 14 days, and 28 days. Here you can visualize and export your actions, usage, and errors. These are sort of high level, so I can see my flow run trend, my failure run, my success, etc. over a certain day. So on the bottom here, we can see that for each day, this flow is designed to only fail. So we can see each day it ran roughly 1,380 times, give or take. And when I export this, I'll see the timestamp. So I'll see 2/5/2022, 1/30/2022 with the 1387, 1389 fields, or excuse me, numbers. But if we want to get deeper, then we have to go into actually alerting off of the history, which we'll look at a little bit later. So we also have the actions and errors as well to look into this. Okay, one more step above is the environment level analytics. So this is found within the Power Platform Admin Center. In the analytics area, you can click on Power Automate and you'll find this here. What this lets us do is isolate to a specific environment within our tenant. To change environments, we click on that change filter that you see in the middle of the image below. And you'll get to pick a instance as well as how far back you want to look. Again, 7, 14, 28 days. You can see there's 6 tabs, including runs, usage, created, errors, shared, and connectors. This is covered both in the Monitoring the Power Platform blog series as well as public documentation on what's included in each one of these. But for this image here, we can see in the runs tab, we have the cloud flow. We can switch over to desktop flow. We have the weekly runs, including the total number and then breaking it down by successful, failure, canceled runs here. And again, these can be extracted into Excel for further processing. Finally, we have a recently announced tenant level analytics feature. So within the Power Platform Admin Center analytics area, if you look in the top right, if you have this configured, you will have the ability to change an option set from environment level to tenant level. If you haven't turned this on, I believe you can go to the settings in the upper right hand corner and then choose how to turn this on. And there's instructions online on how to do that. And once you get that turned on, you can flip over to tenant level analytics. This lets us look across all the environments within our tenant, be able to look at usage, maker activity, and inventory, so we can see what's our top flows in terms of how many runs in the past 28 days, whatever we're looking at. What's the top environments that are running flows? What's the number of successful runs versus failed runs across the number of environments. And on the right, you can see there's filters for filtering to specific environments or types. If I want to look at the developer environments or production or sandbox, I can do that. Environment states or what regions as well. So you can see on the left, you have a nice bar chart with a line showing the number of runs. On the in the middle here, you have the tree map where you can see the bigger ones, and you can click on each one of these and it'll isolate this down. So clicking on get primary sender, for instance, will manipulate all the numbers that you see here. You have the maker activity and inventory that'll show you who's the most active makers, and then inventory looking at like connection references and so on. Okay, for the next part of this bootcamp, we're going to look at how to collect flow runs at scale. So I'm going to cover an architecture that's designed to be able to look at all flows or specific flows within an environment, and begin to collect all of the runs of these flows. So we'll look at the design to identify potentially long-running processes, ones we may not have access to, etc., and how to begin mining for Power Automate flow runs. Scalable architecture. So what you see here on the right is a diagram I've designed to sort of describe a solution that will help us collect flow run at scale. This will include working with both PowerShell, specifically in our case Azure Automation, running PowerShell runbooks. We'll be using Azure services such as Azure Storage Table, and Azure Application Insights and Log Analytics, as well as Microsoft Power BI. So in this case here, we're going to start with a script that is going to help us locate flows in an environment. So in this piece here, what we're going to try to do is essentially go to a specific environment. In our case, we're going to look at production, and we're going to be able to collect flows from there. You can go across all environments, across all flows within a tenant. My recommendation would be to start with a single environment and go from there. So what we're going to do here is look at production specifically. So this script has two main objectives: to locate flows in an environment and to collect the run history. So it will look at the environment, find all the flows, and then make determinations before it collects run history. This is designed for a scalable approach. So what we're going to do is we collect the flows and we're going to ask it questions about its history. So for instance, we're going to ask it, are you potentially a flow that runs very frequently, that has a lot of history, that may potentially become a bottleneck while I'm processing? If so, I'm not going to process. What I'm actually going to do is put you in sort of a queue. So we look for what we call extensive history flow, and we pass that extensive history flow along with its next link to a table in Azure Storage called Power Automate Next Link. The next link will provide us essentially a paging token to get the next 50 runs. So what we do when we locate the flow in the environment is that we look for the input link, and instead of processing, we immediately send that over and continue to the next flow. And that is because we'll have a process that we'll cover next. Next, we look at the flow, where we look to, as we try to get the next link, that will quickly tell us if we have access to the flow. If we get a 403 telling us we're forbidden for this flow, we then again push that one to another table that we've called Power Automate Owner Update. This is an Azure Storage Table. This will allow us to run another process to give us just-in-time access to get what we need, the flow run history, and move on. If we've run into a flow that is not an extensive history flow or a 403 forbidden flow, we actually do collect the flow run history at this time. So we'll collect flow run history using the Power Apps Administration PowerShell. And then we'll push that to Azure Monitor logs using the Application Insights objects. Application Insights in PowerShell by default doesn't have a module, but you can reference a DLL and use the typed objects and pass that in. Alternatively, you can reference the APIs directly, and also you can use log analytics if you want to do this as well. In our case, we're using App Insights. Okay, so that's the happy path, is simply getting a flow and getting the history here. So remember, you'll loop through the flows, getting the get flows or get admin flow with the environment name, and then get flow run for each flow, loop through that, and pass these into the Azure Monitor. So what makes this scalable is these two steps here. So let's look into these. So for the extensive history flow, we've passed these records into Power Automate Next Link. What we have is another process that will essentially ask for these records here. With the next link, it'll get the entities. So we'll use Azure Storage module and the commandlet to get entities to collect the records in this table, and we'll run a collection of run history in parallel. So we'll use parallel scoping to collect these and process these into Azure Monitor. For the forbidden flows, we will pass these to Power Automate owner update and run another script that will also again use the Azure Storage module and get entities commandlet to do two main objectives: assign ownership to admin and collect run history. And while it's being processed, what we want to do is again collect that run history and then remove the ownership. And that's an optional step. You may want to keep the ownership if you're looking at sort of an IT support or admin type approach here, so that you have the ownership, so you don't necessarily have to get back into this. If you have ownership, then this piece doesn't need to exist anymore. So if you remove this, then that flow will again be back in the forbidden flow table here. So if you don't remove ownership, you might look at actually scrubbing that flow from this table. When you're running, especially in parallel processing, when you know you're running against extensive history, expect token revalidation. So you're going to be working with access tokens and refresh tokens. Make sure you're storing those and refreshing your token from time to time. You get that expire time when you get that token issued to you. So you may want to monitor for that and revalidate or revalidate for each between each flow. That strategy would be up to you, but expect that you need to revalidate it. So build that mechanism within. And finally, like we mentioned, separate long-running flow. When you get into the Azure Monitor log, the benefit here is that we can now separate these into requests and dependencies. So in my solution, the workflow itself, the flow itself, is going to be in the request, and the actions will be in the dependencies. This will help us build sort of a distributed transaction model. It'll allow us to leverage some of the App Insights features we have, as well as we can now also use Kusto queries to build out Power BI reports, visualizations, etc. here. So collect history in parallel. So looking at that script, how we're going to use all this, we're going to leverage something called run space pooling locally. And PowerShell and Azure Automation, we can look at jobs and run these as workflows within Azure Automation. So here's a PowerShell example, a script we're going to be passing in to our run space pool. In my case, I use something called I think it's called Posh RS or RS Posh, but this one lets us define the job and then provide sort of this script block, and then tell me how many threads I want to spin up at a time. So I'll be passing in parameters to it, including my application insights input, my header, and my environment name, and then get my flow run history using the invoke rest method, because that lets me kind of control if I'm going to be running paging or not right here. So we can decide how we want to do that. If you do the get flow run, you're gonna get every single run. So that again could be a blocking call. This one allows me to determine if I have an input link and decide to go from there. And then for each one of the values, I could track the flow run. So I have an internal method on this script that tracks the flow run that will put it within the Azure Application Insights. So you can see I'm passing in the App Insights object as $AI, and then the $. For the flow run, and then the flow run itself there. Finally, I'm returning back from my resource pool job my AI, my flow information, and then like any of the workflow information here. Add administrator to flow to collect history. So first, we need to determine if the flow is a myFlow based flow or solution aware flow. If it's a myFlow based flow, we can leverage the modify flow owner action that's included within the Power Automate management set of actions within Power Automate. Or we can leverage the Power Apps PowerShell module and use the set flow owner, I believe it's set flow owner, and give it the appropriate permission. If it's a solution aware flow, we have an extra step that we need to first do, which is to grant access to the process record. So in this example you see on the right, this is a Power Automate flow that is running on a timer. It is getting entities or records from Power Automate flow owner update, looping through these records, and then finding the columns within the table here. What it needs to do is go ask Dataverse information to go find the right record. The key here is that the ID that is used by Power Automate or Process Simple is not the ID of the record stored within Dataverse, but it is an identifier on the record. So we have to run a retrieve multiple on Dataverse and then use the workflow ID unique field. That will help us find the specific record. And finally, we need to use the unbound action grant access to flow, give us access to the flow. Once we do that, then it works the same as myFlow. We can simply leverage modify flow owner or leverage PowerShell. For PowerShell, we can use the set admin flow owner role. So you'll give it the flow name, principal type, and then the role name can edit. So that's the big one. The can edit will give us access to the history. The can view does not give us access to that. Here's the image of the equivalent for modify flow owner within the Power Automate management. So you set the properties principal ID, principal type user, and then what permission it is, which is can edit. Okay, so on this slide here, we're going to try to kind of describe how to take a previous Power Automate run and correlate it to Dataverse monitoring. So on previous monitoring bootcamp sessions, we've talked about how to turn on the Dataverse monitoring. Dataverse monitoring will provide data points when a service such as Power Automate will try to attempt to perform an action on Dataverse. So in our case, we are doing things like adding new rows, deleting rows, updating, retrieving rows within Dataverse within our Power Automate. So for instance, this first call here from Power Automate may be using the Dataverse connector to add a new row. It may also, after that, go do some work and then update the same row, using some updated information from processing that happens here in between. So when we have the Dataverse monitoring turned on, within the request table, we'll actually see the request coming in. What's interesting is that we'll have the user agent will show something like Azure-logic-apps. On the end of it, it'll say something like flow. But what it doesn't really tell you is which flow is actually invoking this request. It doesn't give you the workflow ID, the workflow ID unique field from the workflow table within Dataverse. So it's a little tricky to find it. A couple of options we have are to look at the operation_parent ID. This is part of the output from a Dataverse transaction. So what happens here is this operation_parent ID actually correlates to the request underscore ID. So if you see on line 1, we have REQ_ID. That's a header that's coming from the output of Dataverse that will correlate to this GUID that you see here. So you can attempt to do something that way by capturing the request ID on the real-time monitoring that we've discussed before. Or if you don't have that, another way would be to attempt to either mine through the workflows as we've talked about, each one of the headers if you have that available, or if you don't want to go down to that level, we're actually having to invoke the input or output links to get to that. You can look at the URL of the flow and see when it has that logic app link to it from the input or output, you'll see that part of that URL includes a string looking something like this. This actually is tied to your Power Automate flow. So by using that, in our case, we're going to look at this from the input link. We can take that and actually correlate it back to our Power Automate flow that is run. So what's interesting is once you create the flow, this one will be consistent. When you make updates to the flow, the version number will actually will change. So when you're looking at the user agent, you'll get both the workflow ID, which is from this input link in our example. You also get a version number that can sort of help you know which version of this flow is actually running there. All right, some of the best practices for historical collection. Do determine what status to search for. I recommend starting with just looking at failures, monitoring your failures so that you can stay alerted on those. Start small. Don't expect to collect everything at once. Offload any potential long-running processes. As we showed in the architecture before, some of these flows can be running for very frequently over a time span. So we don't necessarily want to lock up our process mining through each one of those. So in our example, we're actually offloading those potentially long-running flows to a process that is better suited to process those. So maybe it's available to scale out across nodes to process that. Determine what environments you really do want to collect on. This can get very chatty very quickly. I would recommend business critical workloads for sure. You could choose all flows in an environment. You can choose a handful of ones that are pertinent to whatever mission critical workload you do have. So just be mindful of what you want to collect. Start small. Make sure you're collecting everything is working as expected. You've got your alerts, and then decide how you want to build that out. Finally, design for resiliency, scalability, and state. So part of the design that I showed earlier is using things like Azure automation. So we have the elasticity of the cloud, so we could scale that out. It's going to be resilient. So look at how we can store within our case Azure storage tables are stored in some sort of storage. In state, you want to be able to keep the state of the last run. So that's where the next link piece comes from, right? We're attempting to not necessarily capture everything at once. We want to sort of get the delta. So keeping the state of our last run so that we kind of know, where we were and where we need to get to make sure we have the full picture here. All right, let's take a look at how we can monitor flow run history at scale. Okay, so in this example, we're going to show how to monitor flows at scale using both the Power Apps Admin PowerShell module and commandlets, the Process Simple API, and the Azure Storage module and commandlets. So to begin, we're going to work with the Power Apps Admin PowerShell. So we'll add Power Apps account. Username, password, get our token for that. And we're also going to go ahead and get a token for the Process Simple API. You can see all this here, which we'll be using. So we're going to get the flow service token and so on all here. First thing we're going to do is get our flows within the environment using get admin flow. Now I'm going to create an appinsights. By default, appinsights is not available here at PowerShell, but we can use the DLL and use the new object to get our types and then set the instrumentation key here. I'm going to add my subscription with add AZ account here, my storage account name, and the different connections I have here. So I have two storage tables. I'm going to get my cloud table, which is my Power Automate flow. This will be the one for the next link. The Power Automate flow owner is for the flow owner update, or if I get the 403 forbiddens. So once I get all my flows in the environment, I'll loop through. I'm writing some details by connection reference here, but the big one here is I'm first going to run a next link check. So I'm going to run against process simple. Process simple gets my runs. I'm going to see if it has a next link. First, before I get into that, I'm going to just do a try catch. If there's any error here, I'm going to look to see if it's forbidden. If so, I'm actually going to add that into the flow owner. This is how we'd handle the 403 error that we would get if we didn't have access to it. So an example you would get here is the caller with object ID does not have permission for connection, something like that. And that'll be here, and you can write that. Once I get the response for next link, check to see if it's null or not. If it's not equal to null, meaning it's there, it does contain it. We're going to add it to our cloud table and then add some properties here. So this will be the one for further processing. For ones that don't have flows over 100, they don't need to be processed separately. We can get the flow run using get flow run and the Power Apps admin, and then process it here. So we have some methods within that help us track the flow run and flow run action within application insights. Let's take a look at that. All right, so here's the function track flow run. You can see different ways I'm using the request telemetry object here, setting some custom properties and so on. The big thing here is make sure you're setting context. So we're setting a context that you'll see in here. So making sure that we're setting the cloud role name in the cloud role instance, as well as the operation name, and then the operation parent ID is going to be key as we look towards working with action. There's both a flow run and a flow run rest. The reason for this is that flow run from the Power Apps module kind of types it a little bit different than the response would be from process simple. So just how it adds like internal, for instance, on the properties and that kind of thing. What you can see here though is key is adding the custom dimensions, adding into the property bag, environment name, flow, start, end time. This is what's key because appinsights by default won't let us pass in something, write a timestamp that's, I think it's older than 2 hours from whatever the current time is. So to accurately capture when this flow ran, we need to store it somewhere. So in our case, we're storing it in the custom dimensions of the request. Here's the rest call here. It's similar, but there's not, you can see some of these are just the properties and so on here. For the action, you can see I'm using the dependency telemetry object. The big one I think here is setting the context and then setting the, where is it? We're going to set the parent here somewhere. So we're making sure you set the operation ID for the dependency, but then the operation parent ID needs to be the request ID here. So I'm actually collecting the inputs as well, so we can have all that. So looking at things like not equal to fail, setting success, and that kind of thing. So let's see this thing in action. So we see we're getting flows for this environment here, writing out some stuff. And we're trying to connect the various tenants within Azure. We'll go to my tenant here in a second. So now we can start seeing that it's pushing to telemetry context and setting various things here. So it's actually running through these flows and setting appinsights and everything else and collecting that. So we'll let that run for a bit. And again, this is looking at flows to see, are they is it something I should process, or is this something I should go do a pass for further processing with the parallel jobs here. All right, to wrap this up, here is our extracted data within appinsights. So we can see on the request table here, we have what we were sending in from the PowerShell script. So we have the name of the flow, the URL to actually get to that flow. So if I ever needed to say troubleshoot this and go to that flow run specifically, I can do that. See that it was successful with the result code of 200 and the duration in milliseconds. So 1.3 seconds to finish this one up. For our custom dimensions, this is where we stored again our start time when it actually ran, January 14th, and then what environment, what was the flow ID, all the kind of stuff that we have within we have. So there's all the different ones. You can see here, process unavailable, busy, flow, action failed was the result code here. So this one was the failing one that we had showed earlier on the flow analytics here. So there's the run and kind of see what's going on here.
And to wrap it up, here's the dependency. So these are actually the actions within. So get entities, apply to each, and how long each one took. I can see that the action failed in this one. And here's the input and output links, which can take me to the body of this here when it ran. And then I can do the operation parent ID is the run ID of the flow, and here's the specific operation ID. Each dependency, or excuse me, each action, which is the dependency here, has its own tracking ID that you can use here. So that's exactly what this script is doing. And then I can tie all this back to appinsights. And here's the transaction search. I can show a request here that has all my dependencies that are tied to it, and my end-to-end transaction details with the run, and then all the different information I have here, including like the dependencies that were part of this. Okay, so we've finished up our demo about how we can collect the previous flow runs and put those into Azure Application Insights. This image here is actually showing how we're collecting the request from the busy flow name that we have here. So we're checking, when busy flows run over the last 12 hours, looking at extending the start time that we're collecting and looking at the average duration. So we're doing a summarize on the second to last line of the average of the duration, breaking down the start time by each minute here. So you could see below each one of these little dots represents the minutes from the flow. We see there was a spike at 10:45 p.m. here. But yeah, you can use appinsights. What's pretty good about it is that it has the aggregate, like the average and bin, as well as the rendering, the time charts and line charts and bar charts and all of the goodies that we look for here. So it's an example of that. Well, I hope you've enjoyed this session. You can find my contact information there on the bottom right. There's my email address as well as my LinkedIn. If you did enjoy the session, please give it a like and subscribe to my channel for additional videos coming in the future. Thanks.